Okay, so I have here moving on in calculus. This is chapter 5 from Calculus, a first course. This video will cover section 5.1, 5.2, and 5.3, and just really focusing on what you need to know. So before it even starts, it starts to ask you in kind of the intro is how can you tell if your function is even, odd, or neither. So I just wrote out a very, very quick way to tell if it's even. If it's even, if you plug in x or negative x into your function, you get out the same answer. If you have an odd function and you plug in x or negative x, you will get the negative answer compared to what you originally had. So one will be positive, one will be negative. If it's neither, then neither one will happen. You don't have anything related. So for instance, if I'm looking at these three functions, if I have f of x, I already know that that will equal x squared. So if I plug in f of negative x, just see if my pen will catch up here. There we go, but now I wrecked it. Okay, so then if I plug in f of negative x, and then I would plug it in here, and you get negative x squared, and we know if you square a negative, it will be positive. This will just equal x squared. So the fact that we get out the very same thing, that makes this an even function. Now, if I look at f of x equals x cubed, if I plug in negative x, I would get negative x cubed. When you multiply that through, the negatives doesn't cancel, so you get negative x cubed. So the fact that you're getting the negative value of your function makes it odd. And then lastly, if I take a look at g of negative x and plug this in, you're going to get negative x squared plus negative x cubed. So once we do that, I would get x squared, because again, the negatives cancel. And then when I take the cube root, when I raise negative x to the power of 3, the negative does not cancel, and we'll end up minus x cubed. So we're getting a different function altogether. So this would be neither. So that's simply put how you can tell if you have an even, odd, or neither type function. Moving on to the first official section, looking at vertical asymptotes. So if you do look at your textbook or some other information, it might be fairly wordy, but I just tried to simplify it here. If you have a vertical asymptote, it will happen at x equaling a number, and the function will get very, very, very close to that number, but it will never cross. So if you just very quickly drew something here and say we have at x equals 2 a vertical asymptote, again, doesn't matter what your function is, you're getting very close to that, but you're not crossing. If you came from the other direction, very close, but not crossing. So that's my very simple explanation, but then let's go find it. So if I look at my first expression, I have 2 divided by x minus 3. So I know my critical number here is going to be 3. So when I take a look, if I approach 3 from the left, that would mean a value a little smaller than 3, you would end up with a negative. So when you write this out, you'd have a positive number in the numerator and a very small negative number in the denominator. That means with this function that you're going to be going towards negative infinity. So if I drew this out, my graph would be heading in the downward direction. Then in the next part, if I came from the positive side and plugged in a positive number here, so a number a little bit bigger than 3, you'd end up with a positive number divided by a positive number. That means your function is going towards head towards positive infinity. So going towards the positive direction at x equals 3. This next one, if it's not asking you to split it up and it's just saying 5, like in this example, we know that based on what this function looks like, your critical number is 5. That's when you have no x value. So if we take a look at this function and we split it up and we say we're approaching x or the value of 5 from the left, what would happen? So the numerator is going to be negative. If you're approaching from the left and you're taking a look at what's going to happen, the denominator, no matter what, because you're raising to an even power, is going to be positive. This means you're heading towards negative infinity. If we do the same thing, but from the right, again, numerator is already negative. Doesn't matter in the denominator. Once you square it, it's going to be positive. You're still going towards negative infinity. So if I were to just draw a very, very quick example, here when x is 5, if that was my asymptote, then whether I was coming in from the left or the right, it is heading towards negative infinity. Now, vertical asymptotes I do think is fairly easy. Horizontal asymptotes are a little bit more work. So for example, when I'm looking at horizontal asymptotes, oh, I said in my own words, but then I didn't change this to horizontal. Horizontal asymptotes happen when y equals a number, and just like vertical, you're going to get very, very close to that number, but you'll never cross. So just here, things to remember: if your limit as x tends towards positive or negative infinity, then your function f of x will equal a number. So this L is a line, a number, that's what our textbook uses. If you have a function, and same idea, your limit is tending towards positive or negative infinity, and your function is 1 over x to any exponent, that makes the whole thing tend towards 0. And we can talk about that a little bit more, but really we just have to remember it. So when I'm looking at my equation here, and I have, just rewriting this, x squared minus 2x divided by 3x squared plus 1, before I plug in this limit, I want to divide every term by my largest x exponent, which is going to be 2. So I'm going to take my x squared and divide it by x squared. Then I'm going to take 2x divided by x squared. Then in the denominator, I have 3x squared divided by x squared. And then lastly, 1 divided by x squared. Now we can see with this first part, if you have anything divided by itself, it equals 1. Over here, 1x will cancel with one of the x's here. Over here, the x's cancel, you're left with 3. And here, nothing cancels. So now if I plug in my limit of negative infinity, if I have negative infinity for x, this whole term tends towards 0. This whole term tends towards 0. So what I'm left with is 1 over 3. So that would mean that my limit for x is going to be 1 over 3, meaning I'm going to have a horizontal asymptote, this is an awful line, at 1 over 3, and it would be going like this. So we're going to get close to it, but never touch it. Now, my very last question here is just putting it all together. So if I wanted to find my horizontal and vertical asymptote of y equals x divided by x squared minus 6, my first one that I'll look at is my vertical asymptotes. So I would want to factor what I have. So I would have y equals x over x minus 3 and x plus 2. So that tells you your critical numbers are going to be 3 and negative 2. So that's where our asymptotes will be. And then we want to see what is going on. So if you have your limit as x tends towards 3 from the left, and we plug in 3, just a smaller number, we'll get a positive value in the top. And then in the denominator, if we were coming from the left, you'd have a very small negative from the first binomial. And then from the second binomial, you'll get a positive value. So this means you have a positive divided by a negative. So you're tending towards negative infinity. Then we'll do the same thing and take a look at your limit as you approach 3 from the right-hand side. And if we do that and plug it in, you still have a positive value in the numerator since 3 is positive. And then in the denominator, that first binomial will be positive, the second one would be positive, so you're heading towards positive infinity from the right. Now we'd have to do this again with that limit as x tends towards negative 2 from the left. And if we plug in negative 2 into our values for x, we'd get a negative in the numerator. And in the denominator, coming in from a negative, so plugging in a negative 2 for x and minus 3, it will be negative. And then for the next binomial, it will also be negative. So this one, you're heading towards negative infinity. And then we're going to do that one more time, approaching negative 2 from the right-hand side. So negative, because 2 is negative, and then same idea, you're going to get that negative value, and then this time a positive. So this one's going to happen go towards positive infinity. So that is our first bit. So if I was to look at some of my function, and you can always use a graphing calculator to help you here, but then we'll fill in just to understand it. We know at -2 you have a vertical asymptote, and at +3 you have a vertical asymptote. And then based on what we just saw, and you can also note that you do have a point and it goes through the origin, that as you're tending towards 3 from the left-hand side, you are heading towards -infinity. And then going towards 2 from the right-hand side, you're going towards +infinity. So that's our first little bit with the graph. And then we do have some extra part here, and we do know from the right-hand side, or sorry, the left-hand side, we're going towards -infinity. And for our 3 value, we're going towards +infinity. So I'll start drawing that in, but we will also have some horizontal asymptotes. So taking a look at that, I still have that same function, but now I want to divide each term, and I will not use the factored form. I'll just use that same one we had. And I want to divide each term by your highest exponent, which is x to the power of 2. So you have x over x to the power of 2, then x squared over x squared minus x over x squared minus 6 over x squared. We can see some reducing here. So this ends up being 1. This part here will tend towards 0. This will tend towards 0. And the top one, once we reduce it, will also tend towards 0. 0 divided by 1 is just 0. So that means we have a horizontal asymptote happening at 0. So to fill out this drawing, because we know that means when y is 0, we're getting close to it, but not crossing. So same thing on this side, we're getting close to it, but not crossing. And then we've done what we were supposed to. We took a look, found our vertical and horizontal asymptote, and then in this case, added on that drawing. As always, I hope you found this helpful. If you did, please subscribe.
Subscribe for a cookie.
And my daughter has to add that in, but there are no cookies. And I will finish doing one more video for chapter 5 in the next day or two. If you're taking Chem 30, please check out my channel. I also have a website for Chemistry 30 that lists every single topic with a video. Thank you for watching.